This is me Arzu here and I welcome you to my channel Mr. Teeth, where your dental concept get dissected. So the topic of today's video is dental cements, and in this video we will be dealing with this topic properly. And as we know that this topic is too large, okay, so I have divided all those topics of this dental cement, okay, subtopic of this dental cement into many parts, okay. So in this part we will be dealing with the definition of cement, what is it, we will understand that. Similarly, the history of dental cement, the ideal properties of dental cement, okay. After that we will deal with the classification of the dental cement, okay. So dental cement is classified on different bases, okay. So without delaying much, let's start today's topic, okay. So as we know that cement are those substances that hardens from the viscous state to a solid state and to act as a base, liner, filling material or the adhesive to bind devices and the prosthesis to the tooth structure or to each other, okay. So simply the dental cement are those substances, okay, that is present particularly in a viscous state, okay, that hardens to form a solid state, and that solid state would help, okay, would act as a base or the liner, okay. So base is a pulp protecting agent and liner is also a pulp protecting agent, but a base is applied in a larger thickness, but liner is applied in small thickness, okay. So it also can act as a filling material, okay. So filling material as a restorative material also it can be present in a tooth structure. Similarly, it can act as a adhesive, okay, to bind the devices or the prosthesis to the tooth structure. So when we prepare the inlay or the onlay, and for the addition of those prosthesis in the prepared tooth structure, we can use this dental cements, okay. So after that, okay, so binding cements that make object adhere to each other or something serving to firmly unite, okay. So this also wants to tell same point that it simply binds, okay, or adhere anything to the tooth structure or simply act as a restorative material by firmly uniting itself, okay. So now we will study about the history of dental ceramics. So in 1873, okay, there was a discovery of the silicate cement, and it was discovered by the Fletcher, okay. Fletcher discovered the silicate cement in 1873. Similarly, in 1873 itself, okay, zinc oxide cement was discovered by Chisholm, okay. So this is Chisholm, and in 1879 zinc phosphate cement was discovered by Dr. Pierce. In 1930 calcium hydroxide was discovered by the Harman, and in 1968 polycarboxylate cement, okay. So zinc polycarboxylate cement discovered at this time by the Dennis Smith, okay. And in 1971, and this date is important, GIC was discovered in 1971 by the Wilson and Kent, okay. So we can remember those dates, okay. So they can ask sometime in Viva, tell about history of dental cements, okay. So we can say that in 1873 silicate cement and zinc oxide cement get discovered by Fletcher and Chisholm, and 1971 GIC was discovered by Wilson and Kent, okay. So 1968 polycarboxylate cement, 1930 calcium hydroxide, 1979 zinc phosphate cement, okay. So you can remember the name too, okay, of the inventors. After that we will study about the ideal properties of the dental cement, and in the ideal properties of the dental cement includes those things, okay, those properties of any substances, okay, that is required to be a proper dental cement. So our first ideal property for being a proper dental cement is a low solubility, okay. So as how much the dental cement would be soluble, okay. So if it is low soluble, then for a long time it gives us stability and the retention, okay. So low solubility provide us long-term stability and the retention, okay. Similarly, the low viscosity and the film thickness, okay. So if it is less viscous and film thickness is very thin, then it can properly weight the tooth structure and adhere to that, okay. Similarly, it should have high compressive and a tensile strength if it is used as a restorative material, okay. So in such a case, the high compressive and tensile strength is very helpful there. Similarly, the addition to the tooth structure and the restorative material, okay. So it should be adhered to both tooth structure and the restorative material, okay. Similarly, it should have the long working time, okay. So if it have the long working time, we can get a proper time for the manipulation of the dental cement in our oral cavity, okay. After that I have written rapid set at the oral temperature, okay. So as we put the dental cement in the tooth structure, it should set fastly, okay. So that it can be so that it won't be admixed by any other component of our oral cavity, okay, or saliva or the any other thing of our oral cavity. So there will be less impurities in the cement and it can act more efficiently, okay. So the rapid set at the oral temperature is also a ideal property of any dental cement. Similarly, the biocompatibility, it is must, and after it should be anti-carcinogenic properties, okay, and radio opaque. So anti-carcinogenic properties should also be present in any dental cement, okay, and the radio opacity. So when we do x-ray of any tooth, okay, that is filled by a dental cement, that in that tooth we have used the dental cement, then it should be radio opaque, okay. It should be appear in the our radio film. And similarly, another point is workability, okay. So in workability, it should be easy to mix and manipulate, okay. So there shouldn't be any kind of hindrances or any kind of problem during the manipulation of those substances. Similarly, our another point is thermal expansion. And thermal expansion, it should have a coefficient of thermal expansion that should be equal to the tooth structure, okay. So there should be equal coefficient of thermal expansion, okay, to the tooth structures, so that there won't be difference and any kind of problem due to this can't be arised, okay. If the resistance to the micro leakage and aesthetic properties, okay. So after completing the our ideal properties of the dental cement, now we will study about the classification of the dental cement, and it is one of the most important topic of today's video. So on the basis of its application, okay, so on the basis of its application, our dental cement is classified in type 1, type 2 and type 3, okay. So type 1 is a luting agent, okay. So type 1 is a luting agent, okay. Type 1 is a luting agent. So luting agent means those agent, okay, those cement that are used for adhering or cementing the external prosthesis to the tooth structure. So those cements are called luting agents, okay, luting agents. Similarly, type 2 as a restorative, okay. So for the restoration of the cavity tooth prepared, okay. So for the restoration of the tooth cavity, we can use the cement, and the cements are in the type 2 category. After that, there is a type 3. So type 3, it is liner and the basis, okay. So the liner and basis are the particularly pulp protecting agent, okay. So when we prepare the cavity, okay, so we appear it in a external surface of the dentin, okay, so that there won't be so that it would protect the pulp from external stimuli like a mechanical, thermal, electrical insulation, okay. It provides the electrical thermal insulation to that particular pulp of the tooth, okay. So after that, based on the ingredients, and this is very important, okay. So water based cement is there, resin based cement is there, and oil based cement is there. So there are particularly three types: water based, resin based and oil based. And water based cement, it contains GIC, zinc phosphate and zinc polycarboxylate, okay. So you guys should be remember those classification, okay. They can ask you in the theory exam or in the viva exams. So first I have told based on application, type 1, type 2, type 3, and based on the ingredients, water based, resin based and the oil based cement. So water based cement, there is GIC, zinc phosphate and zinc polycarboxylate, okay. So it is easy to remember: GIC, zinc phosphate and zinc polycarboxylate. Those names that are more famous, okay. So those cement that are more famous are included in this water based cement, okay. In oil based cement also there is zinc oxide, usinal and non-usinal zinc oxide. So you zinc oxide usinal and non-usinal, okay. So usinal and non-usinal are present in oil based, okay, and in water based GIC, zinc phosphate, zinc polycarboxylate. In resin based cement, just remember about the composite, think just composite, okay. Composite and adhesive resins and compomers, okay. So they are present in a resin based cement. After that, ADA have classified the cement into two types, okay, type 1 and type 2, okay. So type 1 is a fine grain for cementation, that is for luting purpose, and type 2 is of medium grain for the basis or orthodontic purposes, okay. So ADA have classified cement just in simple two types, okay, type 1 and type 2. Type 1 contain those cement that have a fine grain for cementation and used for luting purpose, but type 2 medium grain for the basis and orthodontic purposes, okay. After that, we will study about the classification of dental cement on the basis of the setting reaction. Okay, so this is one of the most important classification among all those classification. So when most of the teacher may ask you classify the dental cement on the basis of their application, so on sorry, on the basis of their setting reaction. So on the basis of setting reaction, you should tell there is a acid base reaction. Okay, so on the basis of cement that are in acid base reaction, cement of polymerizing, okay, polymerization. Okay, so there is polymerization in the setting of the cement. Acid base reaction takes place in the setting of cement, and dual or tricure cements are also present there. Okay, after that we can see here in acid base reaction we have particularly two forms. Okay, so one is acid and another is base, and acid is presented in liquid form and base is presented in powder form. Okay, so now those liquid and powder are mixed to form a solid mass. Okay, and the examples of this acid base reaction dental cement are zinc phosphate, zinc oxide usinal, zinc polyacrylate or polycarboxylate, and GIC. Okay, so it include all those important dental cements. Okay, acid base reaction, zinc phosphate and the zinc polyacrylate, zinc oxide usinal, GIC. Okay, so when we manipulate in our first year of dental school, we just take a one or two scoop of the dental cement. Okay, according to our manufacturer instruction, we take that powder of the zinc phosphate or GIC. Okay, and after that we also take a liquid. Okay, so that liquid is a acid and powder is a base. Now when we mix both the liquid and the powder, okay, there forms a solid mass. Okay, so it is easy to understand, but just you have to remember that there is zinc phosphate, zinc polyacrylate, and GIC. Okay, as we have earlier read in water. Okay, water based cement, there is zinc phosphate, zinc polyacrylate, and GIC. So these three are present there, and additional is there zinc oxide usinal. Okay, so you guys should remember that. After that, in polymerizing cement, okay, so here is the process of polymerization happening for the set. Okay, so set by polymerization, they are activated chemically or by light. Okay, so it may be chemically activated polymerizing cement or light activated. Okay, now example of polymerizing cement are acrylic polymer, cyanoacrylate, and all other resin cement. So just remember of composites. Okay, acrylic polymer, okay, cyanoacrylate, and other resin cement, and any resin cement, okay, are under this polymerizing cements. After that we have dual and tricure cement. In dual and tricure cement, dual means it is a polymer, there is setting of the cement by both acid base reaction and the polymerizing cement. Okay, in dual. And in tricure means there is a set by acid base reaction, polymerization, and also by both. Okay, sometimes there can be both the method of setting. Okay, so that is tricure. An example is resin modified GIC and the compomer. Okay, so dual or tricure cement means dual acid base and polymerization, and tricure means utilizes all three mechanism of settings, and it includes the resin modified GIC and the compomer. Okay, so just how to remember I will tell you. So as I have told here, in acid base reaction it includes all water based cement. Okay, as I have earlierly told. Okay, so just remember water based cement are those cement that contain famous names. Okay, famous names are present there like GIC, zinc phosphate, zinc polycarboxylate, except zinc oxide usinal, and zinc oxide usinal is in oil based cement, and non usinal is along it. Okay, and composite are in resin based cement. But here we include all those famous names: zinc phosphate, zinc oxide usinal, zinc polyacrylate, and GIC. Okay, and in polymerizing cement, similar with that of resin based cement. Okay, as I have told earlierly, so resin, all other resin cement, composite compomers are in this polymerizing cement. Okay, and how to remember this dual and tricure cement is that, okay, just take one from this and one from this. Okay, so resin modified GIC, so GIC is here, so resin modified GIC is present in dual and tricure cement, and compomer is present here. So as I have told here, told here that resin cement are in polymerizing cement, so just take compomer from here. So resin modified GIC and compomer. Okay, so you can remember in this pattern. After that I will discuss about the classification of dental cement according to the Coombe. Okay, so Coombe gave a classification of the dental cement. Okay, so he he gave particularly three types. Okay, so acid base reaction. So acid base reaction include the cements that are present here. Okay, and in polymerizing material it includes cyanoacrylate, dimethacrylate polymer, polymer ceramic composite. Okay, so just remember this name. Okay, CDP by PDC or CDP you can remember. Okay, so this mnemonic can help you: cyanoacrylate, dimethacrylate polymer, and polymer ceramic composite. Okay, as it is given by a scientist. Okay, so in viva you should tell in such a sequence. Okay, you can't mix here and there. Okay, okay, so that you should remember this mnemonic: CDP. So cyanoacrylate, dimethacrylate polymer, and polymer ceramic composite. Okay, similarly our in other materials there is calcium hydroxide. Okay, gutta percha and varnishes. Okay, so just remember this, it is also easy. Okay, to remember acid base reaction, polymerizing materials, and other materials. So acid base reaction includes this. Okay, but in polymerizing material it includes cyanoacrylate, dimethacrylate polymer, and polymer ceramic composite. Okay, and that is remembered by CDP. And in other material we have calcium hydroxide, gutta percha, and the varnishes. Okay, so now our last classification is of, okay, that is given by Craig's. Okay, so it is also given by a scientist. Okay, so in this classification, so on the basis of their application, okay, so how they are used, okay, on their basis, on that basis zinc dental cement are classified. So as we can see here, there is a final cementation of the completed restoration. So completed restoration, when you do final cementation. Okay, so when we do permanent cementation, at that time we use zinc phosphate, zinc silicophosphate, reinforced zinc oxide usinal, and zinc polycarboxylate. Okay, here also you should just remember a simple trick. Okay, you can take a simple trick that phosphate and silicophosphate, and similarly reinforced GIC. Okay, so zinc phosphate, zinc silicophosphate comes in one category. After that, zinc polycarboxylate and reinforced GOE. Okay, so the cement that is not used in final cementation of complete is a GIC. Okay, as I have the famous name are present here except GIC. Now after that, temporary cementation of the completed restoration, or the cementation of the temporary restoration. Okay, so temporary cementation means for short duration cementation. Okay, for short duration restoration cementation is done by zinc oxide usinal and non-usinal zinc oxide. So this is quite similar with that of oil based cement. Okay, as I have discussed earlier. Okay, so in the oil based cement there was zinc oxide usinal and the non-usinal zinc oxide. So you can remember from that point. Okay, so linking one point with the another point helps you to keep those things in your mind for a longer period of time. Okay, so try to always link one thing with another thing. Okay, so you won't forget those things. After that, there is a high strength base. Okay, and high strength base, just remember zinc phosphate and reinforced GAC, polycarboxylate, and GIC. So just remember this final cementation of completed restoration. Okay, zinc phosphate, zinc silicophosphate, reinforced ZOE, and zinc polycarboxylate. Okay, so take all four those here and just omit this zinc silicophosphate. Omitting zinc silicophosphate, just take the GIC here. Okay, so we can add GIC here. In the replacement of this zinc silicophosphate, we add GIC here. Okay, so we can remember in such a pattern. After that, in temporary fillings. Okay, so in temporary fillings. Okay, so for the short duration filling we use ZOE, reinforced ZOE, zinc polycarboxylate. Okay, so ZOE, reinforced ZOE. Okay, and the zinc polycarboxylate is used here. Okay, in temporary fillings. Okay, so this is very important. Okay, just remember it: zinc oxide usinal, reinforced zinc oxide usinal, and zinc polycarboxylate. After that, there is a low strength basis, and in low strength basis it includes the ZOE, zinc oxide usinal, and calcium hydroxide. Okay, so ZOE and calcium hydroxide. Okay, and liners, calcium hydroxide in suspension. Okay, so we use calcium hydroxide in suspension in liners, and low strength basis ZOE and calcium hydroxide. Okay, so just remember. So sometimes they can ask, tell me the high strength basis and low strength basis. So high strength basis include all those cement, and the low strength basis ZOE and the calcium hydroxide. Okay, so here is a reinforced ZOE, here is a ZOE simple, and in liner we use calcium hydroxide in a suspension. Okay, so liner is a pulp protecting agent, and that is applied in a small thickness. Okay, and the liner have proper property of it have a therapeutic function. Okay, so I will be discussing these liners and bases in my upcoming videos. For now, you just remember liners have therapeutic functions. Okay, and we use calcium hydroxide in the suspension. After that, there is varnishes, and the varnishes we use resins in the solvents. Okay, so resins are simply used, okay, in the solvents. Okay, so solvents are present there like acetone and alcohol, in which we add the resins, and that forms the varnishes. Okay, so resins in a solvent forms the varnishes. Okay, so this was for today, as we have completed the today's topic. Okay, so definition of dental cement, history of dental cement, and with the after that we completed the ideal properties of dental cement, and finally completed the classification of dental cement. And in the classification of dental cement, I discussed it in the six basis. Okay, so two on the scientist basis, okay, according to the Coombs and according to the Craigs. Okay, and other four bases were on basis of the application, basis of their setting reaction, basis of their composition ingredients. Okay, and ADA classification. Okay, so total I have done classification of the dental cement on the six basis. Okay, so most important among those classification is the among setting reaction. Okay, so when simply sir asks you, okay, or a teacher asks you, tell me the classification of the dental cement, simply you should give a priority that the basis, he is asking the basis of setting reactions. Okay, classification on the basis of setting reaction, so just tell that. Okay, so this much for today, and I will catch you in the next video. If you love this video, okay, so if you love this video, please do like, subscribe, and share this video with your batchmate. Okay, till then, stay happy, stay healthy. Tata, bye bye, thank you.